design. So when I talk about starting in programming, we have to go back to 1981, which seems like a long time ago, but I was 40 years old. I didn't grow up with a computer. I didn't grow up programming like a lot of children today. In fact, no one did at the time. No one had computers. I started out as a chemist, and then I became a mathematician. And it was only later in life that I discovered programming. And it was a series of accidents that led me to see the joy of creating programs and being involved as a programmer. So 1981, a long time ago.
It's still very interesting because when we look at programming today, what we see in the landscape is a lot of people who go through programming universities and learn programming there or go through specialized programming courses. So I still think it's quite interesting to understand why, well, how a background in sciences, in mathematics and so on influences your approach to programming, because that is something we don't see a lot in today.
Yes, I agree. And I think perhaps I had an advantage because of that background, especially the background in mathematics. If you've ever taken any graduate courses in mathematics, you know that the goal is to write a proof. And there's a very similar process involved in creating a program, because you're trying to solve a problem of some kind, and the problem involves a series of steps. But the steps that your brain goes through in solving the problem is very different from what you actually create as the solution. And for me, in my long experience of seeing how other people program, I'm not sure they understand that. I think they believe that programming is writing down what the steps are that their brain is taking. And that's not what programming is about. Programming is about writing the solution to the problem in the most elegant. That's a word from mathematics we used all the time. Elegant. I don't see too many elegant programs. What I see is a capture of the way the problem was solved, the steps that were used, the process in solving, instead of the elegant solution. So because I had an understanding of that, I think from the beginning I was a better programmer in a sense.
I know there's a long discussion about elegance in mathematics and in science, and somehow elegance in mathematics seems to be very related to how to say, to the soundness of the theories, let's say, more or less. How do you define elegance in mathematics and how it relates to programming?
I think that if you've never seen, and that's maybe what we're missing, if you've never seen an elegant program or an elegant proof in mathematics, then perhaps it's harder for you to understand it. I think the people in the patterns community were trying to achieve elegance when they talked about the quality without a name, what Alexander meant by those qualities in architecture that speak to us, where we feel like this is a good place. I feel at home there. I can remember the first time I looked at a large program, a program that was really too big to understand. And yet I felt I could find my way around in it. That sense that if I were in a big house, I would know where to go for the kitchen, or this is obviously a closet, or the bedroom is over here, that you feel at home, even in this large structure. The first time I had a sense of that, I thought that's maybe a little bit of what elegance is that it's so intuitive, it's so well designed that it makes me feel at home. And I didn't have to struggle to understand that very large program. I did have to sit on the floor. My boss came over when I was working on that and he said, Linda, what's wrong? Why are you sitting at your desk? I said, no, this program is so big that I need to put all of the modules in different places so that I can go where I need to go. But I knew how to do that. The program was designed so that I could find my way around in it easily. That is a part of elegance.
So I think that's a very interesting point because my impression from reading history about software development is that in the 70s and around the 80s, that's the point when we started to get larger and larger programs. And that's when we actually ended up with a problem because we didn't know how to organize these programs in a way that allowed us to actually change them later or do something like that. And it still seems an unsolved problem in the industry as a whole.
Yes, I agree with you. And I think the transition was made because people moved. I mean, I spent some time writing assembler code and teaching a class in assembler. And if you've ever written in assembler language, you know there are no pieces. There are no modules, let alone objects, which wasn't to come until much later. So how do you structure it? And the answer is you don't. You just write a long sequence of statements, and every now and then you insert go to, and now you run off to another piece, and then you come back, and trying to understand the flow of the argument, the design of the system is almost impossible. So when we made that transition to design, that there should be a design, I'm not sure that we did it right. I think we tried to do it intuitively. I think we tried to do it without really understanding the entire system, so there was no architecture. And what we wound up with was kind of warmed over assembler where we still had a hard time understanding the system as a whole and where those various pieces are. And I agree, there are lots of large systems out there that are still running. NASA, banks, insurance companies, enormous programs that are still written that way where no one alive understands what that program does. It's a little scary.
Yeah, I have seen this, and I have heard many stories about this. I have also worked with a few teams who didn't know anymore what was in their code. So
Yes.
Yeah, it's very. So I realized at one point that perhaps one of the challenges that we have is that we write code in text files and it's fundamentally linear. And this limits our perception and trains our perception to linearity. So we cannot see any more moving parts or dynamics of the system. Or have you noticed that? Do you think it?
Yes. Yeah. And I would add even further, I have a PhD in computer science, and part of the research was around trying to measure what elegance is, to determine in a more exact way what is good design. And along the way, I measured a lot of variables. And what you begin to see is there's a human limit on complexity. I don't know if you're familiar with the work of George Miller, who wrote a paper in the 80s called 7 plus or minus 2. And we think that that's the limit on the understanding of complexity. But what I found is that I think it's smaller than that. I think it's between 4 and 6. So when I was measuring the design of a program, if I saw more than 6 variables, parameters, little pieces, any more than 6, that meant that that part of the system was going to have problems. And you could see that. You could see more errors. You could see more maintenance over time, more changes within that module. The number 6 was almost like a flag that said, we can't understand this well enough. And so it's always going to cause problems. I have measured it, and it is real.
I'm wondering if this has a connection